Hello friends, last time we talked about different types of functional group and their suffixes and prefixes. Today we will look at some examples, but before that let us look at the substituent and their prefixes used. I have given you the table, you can look into it. Like for example, for R we use the word alkyl, for NO2 we use nitro word, for CH2OH hydroxymethyl when it is used as a substituent and the chain is CH2OH, not only OH. Yeah, next is CH2Cl chloromethyl and like that. Now let us look at into some examples. So let us start with our first example. In this, the parent carbon chain is of 4 carbon, that is this. Now we can number it from left hand side or from right hand side. If we number it from left hand side, then we get first, second, third, fourth. While if we number it from right hand side, we get first, second, third and fourth. While numbering it from left hand side, the methyl group gets the second position, while from the right hand side it gets the third position. So the numbering from the left hand side will be correct one. So I'll write here 1, 2, 3 and 4. So name of the compound will be 2-methyl, 2 word because at the second position we have the methyl group. So 2-methyl. Bute word is used because there are 4 carbon in the parent carbon chain. So bute, no unsaturation, so ane. 2-methyl butane. Now let us look at next example. In the next example, the parent carbon chain is this. In this, if we number the compound from the left hand side, then we get the substituent at the position 3 and 4. While if we number it from right hand side, then the position of the substituents will be 2 and 3. So numbering from right hand side is the correct. So name of the compound will be 3-bromo, 3-bromo, 2-chloro. B comes first in alphabetical order, so bromo has been used before chloro. So 3-bromo, 2-chloro. Pent word is used because the parent carbon chain has 5 carbons, so pentane. 3-bromo, 2-chloro, pentane. Now in our next example, the parent chain could be this, or it could be this. Both are of 6 carbon. So now for selecting the parent carbon chain, we have to look into the number of substituents. This chain has 4 substituents, while this one has only 2 substituents, that is this and this. So our parent carbon chain will be this one. So its name would be 3,4. If we number it from left hand side or right hand side, both are getting same positions of the substituent, so it doesn't make a difference. While if we number it from here or from here, so 3,4 diethyl, this is the ethyl group. These are the ethyl groups. So 3,4 diethyl, 2,5 dimethyl, 2,5 dimethyl hexane. Now in our next example, the parent chain could be this, or it could be this one. Now again we will look into the chain which has more number of substituents because the number of carbon atom is same, that is 7. So if we look into this chain, then it has 3 substituents, while if we look into our next chain, this one, it has 4 substituents: first, second, third and fourth. So 4 substituents, so this chain will be preferred. This chain will be our parent carbon chain. Now if we start numbering it from here, then 1 2 3 4 5 6 7, and substituents get second position, third position, fifth position and sixth position. While if we number it from here, then we get 2 5 2 3 5 and 6. Same positions we are getting, but if we number it from this side, then the second position is gained by chloro compound, while if we number it from this side, then methyl group will get the second position. And as C comes first, then M in alphabetical order, so the preference of numbering will be given from this side. So first, second, third, fourth, fifth, sixth and seventh. So the name of the compound will be 2-chloro 3,5,3,5 diethyl 6-methyl heptane. These all just C, E, these are according to the alphabetical order. Now next, in this example, this is the principal carbon chain having 4 substituents and having 5 number of carbon atoms. So if we number it from here, then B gets second position. If we number it from here, then Cl will get the second position. And as B comes first in alphabetical order, so the numbering will be from this side. One, 2, 3, 4 and 5. So the compound will be 2-bromo 4-chloro 3,3-diethyl pentane. 2-bromo 4-chloro 3,3-diethyl pentane. I hope this much is clear. Let's move on to some more examples. Here in this example, be careful because this ET, if अगर इसको खोला जाए तो CH2 CH3 it will form and our principal carbon chain will then become this one. If I wouldn't have opened it, then my principal chain would have been this. You can see it here. If I wouldn't have opened this, then this would have been my principal carbon chain, which would be wrong. So hence, when ET is given, please open it and be careful while numbering it. This will be a principal carbon chain. Now try to number it from both the sides. I am leaving it on to you. If you find some problem, then please write in the comment section. I have written the numbering, the correct numbering and the correct name. You have to try it from the other side also. Why that numbering is wrong, you have to think about it. Okay. So now let's move on to our other example. So our other example is of multiple bond. So the parent carbon chain must include the double bond. So this will be a principal carbon chain. Similarly, number it also from both the sides and try to find out why the numbering from the other side is wrong. I have given you the correct naming of this here. As there is one unsaturation, hence the name ene has come here. Fifth position contains chloro, so 5 chloro. Principal carbon chain is of 6 carbons, so hex. And at second position we have the unsaturation, so 2 ene. Next. In this again we will give the preference to the double bond, so this will be our principal carbon chain. Though this chain is longer and has a substituent, but then too the preference will be given to the double bond. So this will be our principal carbon chain. Now to number this complex one, we write it in a bracket. First of all, it is at the third position of the parent carbon chain, so 3. Now hide this chain, hide this one and number it. It will be 1 dash, 2 dash, 3 dash, because the substituent will get the lowest position. So 1 dash, 2 dash, 3 dash. So it will be 1 dash chloropropyl. And now the substituent is numbered. Now we can number the parent carbon chain. So it has 2 unsaturation at first position and at fourth position. So we will write pent 1,4-diene. Di word because there are 2 unsaturations. Now let us look into another example. In this example, our principal chain would be this. Now we can number it from left hand side or from right hand side. The correct numbering is from right hand side. You will try to think why the numbering from left hand side is wrong. So I have given you the name of this compound. It will be third position contains bromo, so 3 bromo, 4 chloro, hex 1,5-diene. Hex 1,5-diene. Now in this, if I open this ET into CH2 and CH3, then too it will make no difference because our principal carbon chain would contain the double bond. So this would be our principal carbon chain. Accordingly, the name and the numbering has been done. You can look into it. Our last example is this. Principal carbon chain is straight away this one. Now we can number it from left hand side or from right hand side. As the double bond and triple bond are getting the similar position, we know that in that case the double bond is given the preference. That's why the numbering starts from the left hand side, that is from here 1, 2, 3, 4, 5, and the name is given accordingly, pent 1-ene 4-ine. I hope this was clear. Now let us look at more examples. This one has come in AIPMT. I guess its numbering is easy. It will start from right hand side only because first unsaturation is there only. Here there is no triple or double bond. So that's why accordingly the name is given. In this, our principal carbon chain would be this, because this is the only chain which contains both the double bonds. So this chain is the principal carbon chain. Then at second position it has ethyl group, at third it has methyl, so 2 ethyl, 3 methyl. Principal carbon chain is of 4 carbons, so but 1,3-diene. Next, now here we can take this chain or we can take this chain, because both the chains are having a double bond, but the first chain is having a double bond and the next one is having a triple bond. But here in this chain the number of carbon atom is more. Now when the multiple bond number is same, we will look into the number of carbon atoms as per our preference order. So this chain will be a principal carbon chain, and here at fourth position, so accordingly the number has been given. Now the naming is, at fourth position we have vinyl group. This group is vinyl group. So 4 vinyl hept 1 ene 5 ine. Or we can write this group is also known as ethenyl group. 2 carbon, so eth word, ethene word, and yl because it is a substituent. I hope this much is clear. Similarly, 3 more examples are given. It is more or less same, so I am not discussing it. You can look into it, and if you face any problem, please let me know in the comment section. Now we are starting with the alcohol group, means we are starting with the functional group and the prefixes and suffixes, how to use them in the nomenclature. First of all, with this example we will start. Here we have the principal chain having this one. Its name will be given, its numbering is given accordingly. The functional group is getting the lowest position, so it will be numbered from the left hand side. So its name will be, fourth position has bromo because this is also arranged in the alphabetical order. So 4 bromo, 5 chloro. At second position we have all groups, so 2 hexane. Both the names are correct. Like in this example I have given, this chain will be a principal carbon chain because it contains the functional group as well as the multiple bond. So at second position we have propyl, so 2 propyl, but, 3 ene. Third position as ene group, 3 ene, 1 all. Functional group comes at last only, so that's why all group is coming at the last position. Now in this example, a principal carbon chain will be this one. It has 2 alcohol groups, so if we number it from left hand side, then the alcohol groups are getting positions 2 and 5, while if we number it from right hand side, same positions we are getting of the alcohol groups. So now the chain that will be selected as the principal carbon chain having chlorine as the lower position. So if we number it from left hand side, then the chlorine is getting fourth position, while if we number it from right hand side, chlorine is getting the third position. So numbering from the right hand side will be correct one. So if we number it from left hand side, then we get 3 chloro hex 3 ene 2 5 diol. Here it is written. At third position we have chloro group, so 3 chloro hex 3 ene 2 5 diol. Now our next example, principal carbon chain is this. So we can number it either from the left hand side or from right hand side. We will number from the side that will give alcohol group lowest position as possible. So if I number it from left hand side, then alcohol groups are getting 2, 3 and 6 position. While if I number it from right hand side, it's getting 2, 5 and 6 position. So the numbering from the left hand side will be the correct one, and accordingly the name is been written here. It's hept 5 ene 236 triol because there are 3 alcohol groups, so tri word is used. Now next example, in this the principal carbon chain is this one. Similarly we will number it from right hand side and from left hand side. I will start with the correct numbering. You will do the incorrect side. Try to number it from both the sides and predict why the second one is wrong. So here it is first, second, third. At fourth position, this group is known as hydroxymethyl. I've given this in the substituent table. So the numbering will be, at sixth position we have chloro group, then 4 hydroxymethyl, hept 2,5-diol. Now our next functional group is SH. Its prefix that is used is mercapto and the suffix is thiol. So let's look into some examples of this. Here it is. The principal carbon chain is this. So as the double bond and triple bond are getting same position, but here if we number it from right hand side, then SH will get lower position. So numbering from right hand side is correct. So if you number it, I've given you the numbering 1, 2, 3, 4, 5, 6 and 7. So accordingly we'll name the compound. It will be hept 6-ene. At sixth position we have ene group, 1-ine, because E comes first in alphabetical order, then Y. So that's why 6-ene, 1-ine and 3-thiol. Next we have NH2 group. Here the prefix is amino and suffix is amine. So let us look at some examples. In this one, the principal carbon chain will contain both the functional group and the double bond. So this one will be the correct principal carbon chain, and accordingly the name is given 2-ethyl pent 3-ene 1-amine. जब कोई ग्रुप N से directly connected, so we'll write prefix as N-ethyl 2-methyl propamine. This will be a functional group because this is the larger chain and having more substituent. So this will be treated as a substituent chain. I hope you are getting my point. This will be a substituent and it's directly attached to NH group. So N-ethyl for this, and now rub this chain. Now we will look just for this name. So its name will be 2-methyl prop and treat this as NH2 group, propamine. Now our last example. In this our principal chain will be this because it contains a unsaturation. Now in this group is isopropyl group. So N-isopropyl, N-methyl, N-isopropyl for this, N-methyl, and for this ethene amine. Now our next functional group is CHO group. For this the prefix used is oxo or formyl and suffix is al or carb aldehyde. You know when is Al used and when is carb aldehyde word is used. So in this will be a principal carbon chain because it contains CHO. So at second position we have propyl group. This is propyl group. So 2-propyl bute 3-ene al. 3-ene al. group. Next example is this one. Here the principal carbon chain will be this, because it will include both the CHO group, and the number is done accordingly. You can look into it. Our next example is this. Next, let us look at this example. In this example, this is the main carbon. The CHO group is directly attached to the main carbon chain here. That's why, and all three of them cannot be included in the same parent carbon chain. So we excluded all three of them from the parent carbon chain and treated them as the carbaldehyde group. So this will be our main chain, and the name will be 5-bromo 3-chloro hex 3-ene 2,4,6 tricarbaldehyde. Now in the next example, we included this as a main carbon chain. We can exclude the CHO because it is not directly attached to the parent carbon chain. It is attached with the CH2 group here. So that's why we can exclude this. If it would have been attached directly to the parent carbon chain, then we have to exclude all these three carbaldehydes and take main carbon chain as this one. Okay. Now the name is accordingly. You can see here. Now our next functional group is ketone group. Its prefix is oxo or keto and suffix used is -one. Let us look at first example. In this, the carbon chain, parent carbon chain is this, and the name is accordingly 3-bromo pent 4-ene 2-one. You have to number it from right hand side and left hand side both the ways, and then predict which one is correct and which is not. I have written all the correct names. You can confirm your answer from this. Try to do it on yourself. Nextly, here the parent carbon chain is this one, including both the functional group as well as the substituents. I hope it's been clear. Let's move on. Our next functional group is CN group. CN, when C is part of the carbon chain, then we use the suffix nitrile, and when it is not, then we use the suffix carbonitrile and prefix as cyno. So let us look into the example. First one is this. This will be our main parent carbon chain, including functional group as well as the double bond, and these two will be the prefixes, substituents. So its name will be 3-chloro 2-methyl 4-propyl hex 5-ene nitrile. The name is according to the alphabetical order, and nitrile word is used because the C is part of main parent carbon chain. Now next example. This one, here again we have ET group, so prefer it to open it into CH2 CH3 so that you can judge the parent carbon chain easily. So a parent carbon chain will become this one, and accordingly the number is given and its name is given to us. Now next, this one. Here the functional group numbering is given from left hand side. If we number, the functional group gets first, third and fourth position, while if we number it from right hand side, the functional group gets first, second and fourth position. So the numbering will be from right hand side. This is how you have to do yourself. with each and every example. So in our next example, this will be the main parent carbon chain. Similar case as that of CHO. This one is not excluded because CH2 group is here. Main parent carbon chain, and these all will be the substituents, and the name is accordingly 5 bromo, 2 chloro, 4 cyanomethyl hept 1,7 dinitrile. This one is the correct name. Now next group is amide group. If C is included, then it is known as amide, and if C is excluded, then the prefix used is carbamoyl and the suffix used is carboxyamide. So our first example is this one. In this, our main parent carbon chain will be this, including the functional group as well as the multiple bond, and the name is accordingly 4-ethyl 2-methyl hex 5-ene amide. Now in this example, if we look at the chain, then this group is directly attached to methyl N group. This is attached to N directly, and this one is attached to N. This will be our main parent chain, which will form the alkyl group because it has CO group within it. So the one which is having CO group will form the main parent carbon chain. This one will be our main parent carbon chain, and these will act as substituents. Now in this also we have here methyl group and here ethyl. Here methyl group and here ethyl group. So if ethyl is opened into CH2 and CH3, then this will be our main parent group. Now this methyl group, and this phenyl group will act as substituent. So now let us see its naming. Now its naming will be N-ethenyl. We can write it ethenyl or vinyl, but if we write it vinyl, then it will come after methyl group. Okay, so I am taking ethenyl, so N-ethenyl group for this. Now we at the third position we have one methyl group, and at directly attached to N we have one methyl group. So we will write 3, N dimethyl pent word because the main parent carbon chain is of 5 carbons. So pent, no unsaturation is here, so ane word, and then amide. So its final name will be N-ethenyl 3-N-dimethyl pent ane amide. Now our next group is COX group, that is haloformyl group. In this, if C is the part of the carbon chain, then we have oil halide as suffix, and if C is not a part, then the prefix used is haloformyl and the suffix used is carbonyl halide. Now let us look at first example, this one. In this, the main parent carbon chain is this. This will act as substituent. This one means the functional group, and this will act as substituent. Now, in this, the name of the compound here is our main carbon chain. Name of the compound will be 3-chloro. At third position we have chloro as a substituent, so 3-chloro. Main parent carbon chain is of 4 carbon, so but, no unsaturation, ane, and then oil chloride. This is the suffix used for COCl. COCl. If it would have been COBr, then it would be butanoyl bromide. So like that. Next example, this one. Our main parent carbon chain will be this, and our functional group is this, and this will act as substituent. So its name will be, at fourth position we have bromo group, so 4-bromo. Main parent carbon chain is of 5 carbon, so pent. At second position we have an unsaturation, so 2-ene, and then oil chloride. I hope this much is clear. Now let's move on to our next group, that is anhydride group. For anhydride, if C of anhydride group is a part of parent carbon chain, then the suffix used is alkyl OH, and if it is not, then the prefix used is alkoxycarbonyl, while the suffix used is alkyl carbonyl. Now let us move into its example. So our first example is this. In this, the part which contains CO group, that will form the main parent carbon chain. Whether this chain may be too long, it could be ethyl, propyl, butanoyl, or some complex chain also, but this will be our main parent chain. Like for example, I'll show you. In this, here it is only 1 carbon, while here it is 2 carbon, but then too this will form the base name. I hope this is clear. Now let us start with the first example. In this, our main parent carbon chain is of 3 carbon, and substituent is this. So we will write for this. For this we will write methyl, and the main parent carbon chain is of 3 carbon, so prop, no unsaturation, ane, and OH word is used for anhydride, ester. Next example. In our next example, we have this will be the substituent, and this will act as the base name. So this will be ethyl for this, and methane word, because it is of 1 carbon, so no unsaturation, ane, and OH. So ethyl methane OH. Lastly, we have this example. The substituent forms the is of 3 carbons, so propyl. Now here if we number it, first, second, third, 4 and 5, because if we open eta, it will form CH2, CH3, At third position we have a substituent, that is methyl. So after writing this propyl, we have 3 methyl. Now hide this chain for a while. Now we can number it. So 3 methyl pen 2 ene, because at second position we have an unsaturation, so 2 ene O8. 2 ene O8. I hope this much is clear. Now let's move on to our next functional group, that is the anhydride group. In this we have the suffix used, that is oic anhydride. Now let's move on to our first example of anhydride group. This one is a symmetrical anhydride. We call it symmetrical when the chains attached to this O, that is this one and this one, have same number of carbon atoms. That is, here also it has 4 carbon, in this chain also, and in this chain also it has 4 carbon, that is similar. So its name will be butanoic anhydride. We write butane word only once, like this, butanoic anhydride. Now if the two chains are of different number of carbon atoms, like in this example, one chain is of 2 carbon and the other is of 3 carbon, so we write the name separately, that is ethanoic propanoic anhydride. Ethanoic propanoic anhydride. It is written according to alphabetical order as usual. Now our next group is sulfonic group. The prefix used is sulfo and the suffix used is sulfonic acid. So let us look at this with an example. In this, our main parent carbon chain will be this. The numbering will be from that side which will give the functional group the lowest possible position. So I'll start the numbering from here. So 1, 2, 3, 4 and 5. So its name will be 4 bromo. At fourth position we have Br group, 4 bromo, 3 methyl. Main parent carbon chain is of 5 carbon, so pent, no unsaturation ene, and sulfonic acid as suffix. Now lastly we have COH group. COH, the suffix used is oic acid, and if the COH group, the C is not the part of the main parent carbon chain, then the prefix used is carboxy and the suffix used is carboxylic acid. Like in this example, we have this will be a main parent carbon chain because it includes both the functional group and the multiple bond. Now ET will be treated as the substituent here. So we have at fourth position we have Br group, at fifth position we have ET group, at fifth and at second also we have ET group. So 4 bromo 2 5 diethyl hex 5 ene, because at fifth position we have an unsaturation, and then oic acid. Our next system is oxa system. Well, this is basically the ether group. So this is oxa system. In this, the O should get the lowest position while numbering. So let us look at our first example for better understanding. In this is the carbon chain. Here if I number it from left hand side, then the O will get third position. See, like here. And if I number it from right hand side, then O will get the second position. So the numbering from right hand side will be the correct numbering. Its name is written like this. At second position we have oxa group. So 2 oxa, and treat O as a carbon only, so it will be of 4 carbon, so it will be butane. 2 oxa butane. Its general name is ethyl methyl ether, because at one position of O we have ethyl group and at one we have methyl, so ethyl methyl ether. Now in our next example we have 2 oxas group, this and this. Similarly we have to number it from left hand side and right hand side. The one which will give the 2 oxas lowest position will be the side from which the numbering is to be done. So I'm writing the correct name. You try it from both the sides. So let us number it 1, 2, 3, 4, 5, 6 and 7. So at 2 and 5 position we have oxa group. So 2, 5, its name would be 2, 5 dioxa and treated as carbon only, so heptane. I hope this much is clear. Now we move on to our cyclic ether. In cyclic ether, this group is known as epoxy group, meaning this O and this is attached to carbon and it forms a chain, or ring. It forms a ring like this. It forms a ring. In between this we can have more carbon, like in this example we have 3 carbon atoms, so it's possible, but it should form a cycle like this. This is a cycle or a ring. Okay, so let's look at the first example. In this we number it like this, first and second carbon, so epoxy ethane. Its tribal name is oxyrene. Now next example. In this we number the compound such that the carbon which is attached to oxygen gets the lowest position. So if I number it from here, that is 1, 2 and 3, then the epoxy group will get 2 and 3 position. While if I number it from this side, then the epoxy group will get first and second position. So that's why I've numbered it from this side. So the numbering name of the compound will be 1, 2, 1, 2 epoxy, and the carbon chain is of 3 carbons, so propane. And lastly, let's look at this. So if I number it from this side, then it gets third and fourth position. While if I number it from here, then it will get 3 and 5 position. So numbering from this end would be correct, this side. So let's name the compound. The compound name will be, at second and fourth position we have epoxy group, so 2, 4 epoxy. Then at third and fifth position we have methyl groups, so 3, 3, 5 trimethyl. The carbon chain is of 6 carbons, so hexane. So these were all the functional groups. Now we will look at the names of the polyfunctional groups, meaning having more than one functional groups. The one which is having more priority will form the base name and rest will be treated as the substituents. Now let us start with IUPAC name of polyfunctional group. So let us look at our first example. It is having this functional group, hydroxy functional group, and amino functional group. But CHO group, aldehyde group, comes higher in priority order, so this will form the base name, and these two will be treated as substituent. So this will form our base name, and this will be our main parent carbon chain including the functional group. So now let's name the compound. At third position, it is having amino group, this, so 3 amino. At fourth position it has hydroxy group, so 4 hydroxy. Pent, because the main parent carbon chain is of 5 carbons, so pent, no unsaturation ane, and al for aldehydic group. Next is this one. In this again, this will form the base name. COH group will comes highest in the priority order, so it will form the base name, and rest all will be treated as the substituent. So now let us write its name. Its name will be at third position. We have amino group, so 3 amino. At second we have bromo, 2 bromo, and main parent carbon chain is of 5 carbons, so pent. At third position it is having an unsaturation here, so 3 ene, and base name is oic acid for it. Here are some more examples I have given. You can take it screenshot and try it, and if you face any problem in any example, please do write in the comment section. Okay. I have named them, I have numbered them. In this example, this will be the main parent carbon chain, and this group will form the base name, and rest all will be treated as the substituent. So look at its name. It will be at third position we have an amino group. At third position only we have this group, that is carbamoyl group, because it is acting here as a prefix, so carbamoyl word is used. At second position we have hydroxy, and the main parent carbon chain is of 3 carbon, so prop. At second position we have an unsaturation, that is ene, and lastly we have the suffix, that is oil chloride. I hope this example is clear. Now in next one, this will form the main functional group, so this will be our main parent carbon chain. This will act as substituent. So let us look at its name. At fourth position we have this. Its name will be, as it is of 2 carbons, so ethanoyl oxy. When it is used as a prefix, then we write the CO group as this, COO group as this. So at fourth position we have ethanoxy, and main parent carbon chain is of 5 carbons, so pent and oic acid. We can write this as acetoxy also, because acid word is used for 2 carbons, so acetoxy pentanoic acid. Now in our next topic we have complex substituents, meaning like these type of substituents. In the substituent also we are having more branches. So let us look at one first example of this. Here this will be our main parent carbon chain including the multiple bond and the functional group. Its name could be, first is 3 isopropyl, because this group is an isopropyl group, we can write 3 isopropyl pent, because main parent carbon chain is of 5 carbon, so pent. At fourth position we have an unsaturation, so ene, 4 ene and oic acid, or we can write it as at third, hide this chain and number it here, so 1 dash and 2 dash. So at third position of the main parent carbon chain we have 1 methyl, this one, and this carbon chain 2 carbon, this chain is of 2 carbon. Yeah. So 1 methyl ethyl, this is at the third position of the main parent carbon chain, and then the name is pent 4 ene oic acid. And our next example in this category is this one. In this, our main parent carbon chain will be this. These two will act as substituent. When the substituent are complex, then we write it in a bracket, and also we use, and if there are more than one substituent of similar type, then we use the word bis, tris, like that. So here we have, this is the main parent carbon chain. Hide this one and number this chain. If we number it, then 1 dash and 2 dash. At 1 dash position it has a chloro group, so 1 dash chloroethyl main parent chain is of 2 in the substituent, so ethyl word is used. And similarly this group is also same, so we write bis. At third and fourth position of the main parent carbon chain we have these two substituents, so bis 3 4 1 chloroethyl hept, main parent carbon chain is of 7 carbon, so heptanoic acid, oic acid for COOH group, this one. I hope this much is clear. This is all for today. In the next class we will discuss about the IUPAC name of cyclic compound, aromatic, bicyclo and spiro, and this will end with our chapter of nomenclature. Thank you. For any queries, please write in the comment section. And if you enjoyed learning, please do like, share and subscribe. Thank you.